Hello everyone. Today we will learn how to solve lime soda numericals using simple methods. This topic is included in softening of water using lime soda treatment. So what is the basic formula in lime soda process? The basic concept is lime, that is calcium hydroxide, and soda, that is Na2CO3, are the reagents which are used to precipitate the dissolved salts of calcium plus 2 and magnesium plus 2, and they are converted to CaCO3 and MgOH whole twice. The precipitated calcium carbonate and magnesium hydroxide can be filtered off, and thus the water becomes soft. So this calcium carbonate and magnesium hydroxide is found as precipitate when treated with calcium hydroxide and in sodium carbonate. So to perform this reaction, we need to calculate what amount of lime and soda is required. So we have taken the hardness producing substances on left hand side, and then we have seen how they react with lime or with soda so that they are converted to corresponding salts of calcium carbonate and magnesium hydroxide, and from the extreme right we can find out what amount of lime and soda is required. So if you go through the table, you can notice that this is temporary calcium hardness, that is calcium bicarbonate. It requires 1 mole of lime to convert into calcium carbonate and water, so we have written L here. Similarly, magnesium bicarbonate, this is temporary magnesium. It requires 2 moles of lime because in first step magnesium carbonate is formed, which is soluble in water. So in second when the second mole of lime reacts, then it is converted to calcium carbonate and magnesium hydroxide. So 2 moles of lime are required. Third is calcium, permanent calcium source. Permanent calcium, we all know it is calcium sulfate, calcium chloride, or calcium nitrate. All these three come under calcium plus 2. So this reacts with soda to form CaCO3 and corresponding sodium salt. For example, if it is SO4, it will give Na2SO4. If it is Cl2, it will give Cl2 and NaCl, and it will give NaNO3 if it is calcium nitrate. So this requires 1 mole of soda. Permanent magnesium, it requires 1 mole of lime and 1 mole of soda, because in first step, if we remove magnesium hardness, then calcium hardness is generated. So in the second step, soda is required to remove calcium hardness, permanent calcium hardness. So the requirement becomes L plus S. In case carbon dioxide is dissolved, then 1 mole of lime is required. In case of free acids like HCl, H2SO4 and HNO3, all three can be represented as H plus, and if we write general reaction, then H plus is reacting with CaOH whole twice, then converting into corresponding CaCl2, CaSO4 or CaNO3 whole twice. Then again L plus S is required, because in the second step we require removal of permanent calcium hardness. Same is the case with ferrous sulfate, which is used as coagulant. Same is the case with aluminum sulfate, which is again used as a coagulant, and we require L plus S. In case of sodium aluminate, a little bit different reaction is seen. Sodium aluminate, the requirement is actually deducted because it is minus L. Why it is minus L? Because when sodium aluminate is dissolved in water, then it produces NaOH and aluminium hydroxide. Aluminium hydroxide is gelatinous in nature and it traps the colloidal impurities, but sodium hydroxide generated reacts with permanent calcium or permanent magnesium hardness to convert them into lime. So this is lime formation. This much requirement of lime is not to be added. It can be similarized to if you are having a requirement of 100 rupees and you are already having 90 rupees, then you will borrow only 10. So this requirement is deducted. So the thing which is already present with us need not to be borrowed. Similar is the case with bicarbonate ion. If bicarbonate ions are present in water, then they are the source from sodium or potassium bicarbonate, and in both cases we generate carbonate ions. That means either we generate Na2CO3 or K2CO3. So this much amount of soda is less required, so it is L minus S. Now these two are spatial reactions. So NaOH produces NaLO2, by NaLO2 reacts with hardness, and similar is the case with sodium bicarbonate or potassium bicarbonate. So in one case lime is subtracted, and another case, this case, soda is subtracted, but it requires lime. So we are having requirement as L minus S and minus L. In these all constituents, whatever we have learned, are present in raw water. Okay, but if the water is treated and some constituents are found, then there is a probability of carbonate ions and hydroxyl ions if both are used in excess. So if lime is excess, then it will generate calcium ions which are removed by soda, and in spite of removal of calcium ions, soda is excess, then sodium carbonate is excess. Therefore, what will be the requirement or the back calculation? That is, soda was extra, and the L plus S. Lime was also extra, plus soda was extra. So if the requirement is back calculated, both are added in the soda and lime both. Now the problem comes how to remember the whole table. It is very difficult, it looks very complicated, and the other thing is how to derive the formula. So formula, how we have derived: total lime required for softening can be calculated as L is equal to 74 by 100. Why we have done 74 by 100? 100 parts of calcium carbonate can be converted to, can be 74 parts of lime. So 1 will be required unitary method, 74 by 100, and X will be 74 by 100. And what is X here? X is whatever type of hardness is present in water which is requiring lime. Similarly, we can write it with soda. How soda? Soda is 106 by 100. And how it came 106 by 100? 100 parts of CaCO3 to 106 parts of Na2CO3. One part will be 106 by 100 and Y parts will be 106 upon 100 into Y. It is also unitary method. And now what is Y? Y is Y1 plus Y2 plus Y3, and these are Y1, Y2, Y3, Y4, Y and so on. So in this way we can derive the formula by looking into the table. Wherever the LL is coming, all the values are added, and wherever the SS is coming, which are added, and the subtracted values are of sodium aluminate and soda bicarbonate. So now how to remember this table? There is a very simple trick. What we are doing, we are tabularizing all three values. One column is for simple lime, the other one is for simple soda, and the third one is for lime and soda both. So this is for simple L, this is for simple S, and this is for L plus S. Now what we have seen the formula or the table, whichever is comfortable to you, and we have noted that temporary calcium requires lime, 1 mole of lime. We can verify it with the help of looking into the table. Look, temporary calcium requires 1 mole of lime. So now this summary table is derived in such a way that temporary calcium requires 1 mole of lime. So we have written L, S and L plus S. Temporary calcium is lime, 2 into temporary magnesium. Carbon dioxide requires lime, bicarbonate requires lime, and sodium aluminate is subtracted from the lime requirement. Similar is the case with permanent calcium carbonate ions and bicarbonate ions. If they are present in water, they will require soda or deduction of soda. Here in all 4 cases, permanent magnesium, iron, aluminium, hydroxyl ions and H plus. Source of H plus is HCl, H2SO4 and HNO3. In all 3 cases, the requirement is L plus S. So if you remember this table, then any type of numerical can be solved, and the reaction table is also can be memorized. So in next step we will try to solve a numerical problem. Look at the question. Calculate the quantity of lime and soda required to soften 50,000 liters of water containing the following salts. Now what is magnesium chloride? 9.5 ppm, and this is the data given. How we can calculate? We can calculate, suppose it is 9.5 ppm. So first step is to convert it into multiplication calcium carbonate equivalent. So we will divide this by 100 upon 95, multiply it 100 upon 162 into 100 upon 136 into 100 upon 146. NaCl does not impart hardness, so this is not included in the calculation. Here the values are in such a way that answer for all values is 10. So we are having only 4 salts, all are having 10 ppm answer. 1, 2, 3 and 4. Now we will see, this is permanent magnesium, so it requires L plus S. This is temporary calcium, so it requires 1L. This is permanent calcium, it requires soda. It is temporary magnesium, it requires 2L. Now what we will do, this is done on the basis of that summary table or the reaction table, whichever you are comfortable with. Summary table is easy to remember. So L formula is 74 by 100. Now add all the L's. L is coming in first, MgCl2, 10. Second, temporary calcium, again 10. Third one is skipped because it is only soda. Fourth one is 2 into 10, that is 20. This is multiplied with volume of water, which is 50,000. This answer comes in mg. It is converted to kg by dividing it by 10 raised to power 6. So now whatever the answer comes, that will be this much amount of kg lime. How to calculate soda? Soda is 106 by 100. Soda is with MgCl2, so 10 plus again calcium sulfate, so 10 plus 10, 20, multiplied by 50,000 volume of water divided by 10 raised to power 6, that is to convert it into kg. Now whatever answer is received is known as quantity of soda required. So in this way we can solve the lime soda numericals very easily. Now we will try one more question. This is solved example already. So what data is given here? Calculate amount of lime which is 90% pure and the soda is 93% pure for purification of 40,000. So constituent present are these 1, 2, 3, 4, 5, 6. Here again NaCl is given which is not imparting hardness. So we have calculated every salt is converted to 100 upon 100, that is 25. Calcium sulfate is coming 5. Magnesium sulfate is 100 upon 120. So first step is convert into calcium carbonate equivalent hardness 12.5. Now this is temporary calcium, so it will require L. This is permanent calcium, this will require S. Similarly, this is permanent magnesium, this is requiring L plus S. This is MgHCO3 whole twice, that is 2L. Calcium chloride, that is S. Now we will add all L's, like 74 by 100. What is the value here? 25. So we have written 25. Now where we can see L? Here, that is 12.5. So we have written 12.5 here. Twice of L, that is magnesium bicarbonate. So it is 2.2 into 25. 40,000 is volume of water multiplied by 100 upon percentage purity of that lime compound. Because if the lime is 90% pure, that means the 10% amount we have to add extra, and that 10% is also of 90% pure. So we have introduced this factor so that the total amount will be more. So it comes in mg. Now this is divided by 10 raised to power 6 to get the answer. Same is the case with soda. Here we will write 5 because soda is here, and 12.5 again it will be added here. 24.95 because CaCl2 is consuming soda. 100 upon 93, that is 93% purity, and 40,000 is volume of water. Then again it is converted to 10 raised to power 6. It comes to be 91.93 kg. In this way we can solve the lime soda numerical in simple way. Now the main thing is, take a screenshot of this table and remember this, and then you can easily solve any type of numerical. Thank you.